Hi, my name is Wang Yanxi. I work at HP. In today's talk, I will give you a brief introduction of UEFI and its use cases. Then I will talk about UEFI features that are supported in Ironic. So UEFI is a standard interface between operating system and platform firmware. This is a list of key features supported by UEFI. Just to highlight a few, UEFI can boot from a disk drive greater than 2 terabytes. It supports secure boot, which can be used to mitigate security risk from malicious firmware and operating system. UEFI also have a embedded software stack to support iSCSI and HTTP boot. So unlike iPXE, it doesn't require PXE channeling to channel the firmware, and so it can support those advanced boot features without channeling. Some of the option card, like a NIC card, only work in UEFI, and so the system need to boot in UEFI mode in order to use those option cards. So before I move on to talk about the UEFI features supported in Ironic, I want to give a very quick intro of Ironic and Ironic idle drivers. So Ironic provides OpenStack Baremetal provisioning and management services. It has an extensible architecture that allows vendors to plug in their driver to manage their hardware. And idle driver is a plug-in driver for HP Poland servers. Currently, we have 3 idle drivers, the PXE idle drivers, and 2 PXE idle virtual media drivers. This driver integrates idle and Poland features with Ironic, so it can be used to enhance security, reliability, and manageability when you deploy OpenStack Baremetal on Poland servers. The good thing about these drivers is support the standard Ironic API and CLI, so user can just use the standard API without using any HP specific API to provision and manage Baremetal nodes. HP contributed UEFI boot mode support to Ironic in Juno, and in Kilo release, we added a secure boot support and also the firmware setting to reset secure boot mode and secure boot key as part of the node cleaning function. We also modify the Nova Ironic web driver to allow a user to specify UEFI and secure boot as the Nova boot flavor. Okay, and currently we're working on using UEFI iSCSI boot to boot from Cinder volume. So UEFI boot mode currently is supported in PXE IPMI tool driver and all 3 idle drivers, as well as in IRMC drivers. In PXE IPMI driver, because the limitation of the IPMI tools, it doesn't really work well with the UEFI mode, and so it requires manual pre-configuration of the UEFI boot mode and boot device for every Baremetal node that is going to boot in UEFI mode. For idle driver, we support boot mode management, which means that the driver can detect the current boot mode setting, and it will automatically switch from UEFI to from BIOS to UEFI mode as needed if the UEFI boot or secure boot has been specified as the Nova boot flavor. The driver can also dynamically configure the UEFI boot devices, and so there's no manual pre-configuration is required. We have iSCSI idle and agent idle driver. Both drivers use idle virtual media to boot the deploy and user images, and so it's PXE-less. It doesn't require to set up any TFTP server in your deployment environment. The iSCSI idle driver is provision user image from Ironic conductor, so it's suitable for Baremetal node that has a smaller RAM size. Agent idle driver, on the other hand, it provision the user image from the bare metal node directly, and so it will help the Ironic conductor to scale up to support more bare metal nodes. So let me move on to Secure Boot. And so Secure Boot is supported in Windows 2012 and beyond, and many Linux distros, including Red Hat, SUSE, Ubuntu. And Secure Boot doesn't have any hardware dependencies on TPM, and it's purely implemented in UEFI itself. It's built on chain of trust and validations. So each piece of the boot component needs to be digitally signed, and the signature database is embedded in the system ROM. And signature of each component will need to be validated by the previous component in the trust chain before it can be executed. So it can be used to prevent the loading of unauthorized option ROM, bootloader, kernel, and some of the distro even support Secure Boot for kernel modules. Secure Boot is only available in Ironic idle drivers. Ironic idle drivers can discover whether a bare metal node supports Secure Boot. If it does, then you will set the Secure Boot capability to true and then record that information in the Ironic database. And then user can create a Secure Boot flavor and use that with Nova Boot. So Nova Scheduler will select a node that can support Secure Boot and then spawn the bare metal instance. We also add this image builder element for user to create digitally signed, deploy, and user images. We're working with Hitachi to define a set of API to integrate Ironic with Cinder. Ironic driver, we submit 3 specs, and then those specs are currently under review. And Ironic idle driver will use those API driver to support UEFI iSCSI boot from a Cinder volume. Ironic, the idle driver will discover whether the bare metal node support UEFI iSCSI boot and set the node UEFI boot iSCSI boot to true and record that information in the database. And then you will use the out-of-band idle API to configure the iSCSI target information. UEFI then on the bare metal node then will use the built-in iSCSI initiator to boot Cinder to boot from a Cinder volume. This thing is kind of off the. Doesn't cover all the content in the slide. So this solution does not depend on iSCSI initiator on the option card, so it can work across the different cards from different vendors. So this is the sequence for boot from a Cinder volume. So user initiate a request to Nova and say that I want to boot a bare metal node from a specific Cinder volume with the iSCSI boot capability and as a flavor. Then Nova scheduler is going to find a node that supports iSCSI boot, and it will then get the Cinder volume, get the volume connector information, and then attach the Cinder volume to the Nova. And Cinder will send the target information, iSCSI target information, to Nova, and Nova then will write those target information to the bare metal node instant information, and then will spawn the bare metal instance. From the idle side, idle driver side, idle driver will use the out-of-band idle API to configure the iSCSI target information for the bare metal node. and it will reset the server. And during the boot process, the UEFI on the Baremetal node will read the iSCSI boot setting from the idle, and then it will connect to the Cinder volume and start the booting. And it also pass the iSCSI boot setting to the operating system, and that so that operating system can connect to the Cinder volume and find the root device and boot up the operating system. So that's how it works. If you're interested in Ironic or idle driver, we have wiki. We also have the contact us information. So if you have any questions or you'd like to see any additional UEFI features to be integrated into Ironic, please send us your input. So that's it. Thanks.